Hi, everyone, and welcome to this DCD Talk. I'm James Raddings, Digital Portfolio Lead here at DCD, and today I'm joined by Becky Wacker, who's Vice President of Data Center Solutions over at Trane. Thank you very much to Trane for sponsoring this. And today we'll be talking about optimizing power, cooling, and lifecycle performance. So great to be with you, Becky. And just before we get into the meat of the topic, could you tell us a little bit more about yourself and what you're up to at Trane?
Yeah, I'd love to. Thanks, James. I'm really glad to be here. Looking at the questions we have, they're pretty exciting. But what I'm up to at Trane, as you said, my title, but that can mean many things. I lead the sales and fulfillment for Trane for the data center business. So the folks that work with our customers very deeply to understand where they're trying to go, what their business needs are, and how we can help them solve many of those thermal management challenges that we see in data centers, as well as the people that then turn around and deliver those solutions. And so my purview is, of course, HVAC equipment, as everyone knows Trane for very well, but it's also our day two services, as well as our controls and digital portfolio.
Yeah, and it's great to see, AI is changing so much, but it's great to see that cooling conversations are now including power and life cycle performance, across the deployment and delivery of this infrastructure. From your perspective, what has fundamentally changed between, power, cooling, and compute? And I suppose, why are we having the conversation of all three of them in the same breath now?
Yeah, it used to be easier where the compute was pretty steady and we could think about the cooling and the power as a pretty linear equation, if you will. Now, with the way a lot of the AI workloads are working, not only are they hotter, everybody knows that, but they're also spikier, if that's a verb. And so when we see that kind of situation from a thermal and power perspective, it takes a whole lot more planning, because both the cooling and the compute is going to use that power, and they're going to need to ramp up and down. So as we think about the different workload densities at the chip, and as they get hotter and as they get more powerful, thinking about how we can react faster to that. We can't just look at the chilled water loop and say, good enough is good enough, and let's just keep it steady and make sure that it doesn't get too warm or too cool. It now becomes needing to be a lot more dynamic, tied to what's going on with the compute, and be able to predict as it's warming up, and know that that's coming a whole lot faster than it used to.
Yeah. Now, I'm really glad we've moved away from the AI equals hotter workloads on like the first question, because like you say, spikier, and they fluctuate a lot, and they fluctuate very, very quick as well. From how does that, I suppose, what do operators need to understand about that, and why does that require a different design approach?
Well, I think the biggest issue that operators run into is really how the system reacts in totality to it. And I like to joke that data centers are making data centers more smart and more capable, more efficient, and those different pieces. What I mean by that, in actuality, is being able to apply AI and understand things like, where is the workload changing, where is it hottest, where is it coolest. That can certainly be at the servers in the chips, and where the training is actually happening within the data center. But that can also happen on the thermal side as well, where depending on which piece of equipment is serving which area of the data center, you can get things like heat islands and different thermal conditions that are impacting the ability for that equipment to cool. And so as we think about how all of that ties together, we need to be able to, as I said before, predict where it's going. But also we can now start thinking about which machine should we be using, which one should we ramp up, which one should we ramp down, what percent of cooling are we required in these different places, and really get beyond the just provide cooling standpoint that I talked about on the front end, but now being able to say, as it spikes, we need to look at where exactly that's happening, and that requires a much different design thought process and a lot different tools around controls and digital layers that we put in as we control the different system components.
Yeah, and really shifting to that systems approach as well. I know when we spoke previously, you mentioned the best AI facilities as being not, co-designed, not assembled. Could you walk us through what that means in practice and why that's important?
Yeah, it used to be where you saw a lot of data centers being built in certain areas, and it was because those areas had characteristics that were very favorable. As we look at as the landscape evolves now, we're seeing data centers being built in many different locations that have many different characteristics. And when I say characteristics, it could be how hot the environment is in that space. It could be power availability. It could be water availability. It's likely all three mixed together with certainly other conditions as well. So it's a lot harder to say, let's just cookie cutter our design and we can set it down and every data hall is going to be just fine no matter where we put it. It's a lot more looking at what kind of PUE we need to hit, what kind of WE or water use efficiency, as well as what will be that power that's used on site. We're seeing more and more in this environment of power use being difficult. We're seeing more and more on-site generation, either supporting the grid or being its full island on its own from a microgrid perspective. So we need to make sure that as we are designing our systems at Trane and as we're thinking about how our customers are designing the entirety of their data center, as well as the different data halls and how they tie together, we need to be thinking about not only the components of day one, but how is it all going to tie together? And we need to be thinking about the efficiency. Because as I said in the previous question, no longer can we just apply the simple systems. We now need to have the digital tools to be able to shift load and pull those different pieces together. If you're just cookie cutter, a few components from one place, a few components from another, and we're not thinking about how that entire system pulls together, we're going to have a much less optimized data center than we're going to, which in the end of the day will impact the compute power at the chips.
Yeah, orchestrating it all and I suppose essentially getting everything singing off the same hymn sheet for better outcomes. As well, we're in a very fast changing industry, even recent announcements on warm water cooling, silicon level thermal management, that naturally changes the way how operators design AI infrastructure. I suppose from your perspective, how are you responding from that and how are you seeing your customers respond to that?
We're seeing a lot of our customers maybe not ready to take the full leap into the newest technology today, or not ready to say this is how we're going to design the entire data center, or my existing data centers are ready for this. So a big piece that we're seeing in the industry right now is our clients looking at it and saying, how do I be ready for the shift in the change in the different demands that are coming? And how does the thermal loop tie into that? So it's becoming more and more a conversation at the table around what's my plan today? How is it going to shift as we go along? And really being able to understand and pinpoint where those different heat loads are going to land and how we're going to have to be able to extract those, largely moving towards a lot of liquid cooling. But there's also a lot of innovation coming beyond just liquid cooling to full immersion and who knows what will be next. That's the really fun part with our engineers. But those conversations with our customers and our clients, they're much more future oriented than they may have been in the past, where it was, this is my data center today that I want to design. Now it's, what's our strategy going into the future? And we're building those joint strategies together to best try to predict what's coming, as well as be ready to modify it as that future comes to fruition.
Yeah, and having that embedded flexibility, and I can imagine that the R&D departments are very, very busy people at the moment as well. So, and looking a bit beyond deployment, once everything's deployed, what role do the lifecycle services play in keeping AI infrastructure efficient, resilient, but also future ready, if you will, for some of the changes that we've discussed?
Yeah, let's put it on the table. The data center, like the hypothetical data center that's flipping the switch to on today, was designed for conditions that are already obsolete or out of date. And so any data center coming up is going to be facing that same reality. And it's not because any of us are doing a bad job innovating. It's because we're doing such a great job innovating that things are changing rapidly. The other piece that I look at with a lot of clients and talk with our R&D engineers, as you spoke about, is the fact that the size of a data center just over the past 5 years, the initial build has grown 5 to 10% or 5 to 10x, depending on where you're starting and where you're landing. But that's a huge change. And so what we had seen most recently is if I've got old technology in an older data center, well, it was so small that the new data center can kind of absorb that compute power, and we could focus very strongly on that new construction aspect. As the industry matures and as we move beyond building a 5x or a 10x size data center every time, I suspect that will be the case. It's hard to go much bigger than a gigawatt at this pace, but I could be totally wrong, James. But as we start thinking about that, when it comes to a life cycle, I think what's really important is to have a team to co-innovate with you, to understand where are we today and how do we design to make sure that retrofits are possible in the future as things change. And we can guess what those items will be. That will likely change. How do we also make sure that with the spiky loads that we referenced today and that we see quite often, how do we make sure that the way that we're running our data centers is as efficient as we designed it to be? And as those conditions start to get the wear and tear that you would see on any type of mechanical solution, that we're staying up front and we're finding it faster than just waiting for something to fail, because that's not a condition that we can have in the data center space. So I really think about lifecycle from two pieces. One is keep it running the way that we designed it to, and understand that these systems are working far harder than any other system in any other vertical market that I've ever seen before. And then also, don't think about installing today and waiting for the future to say, well, when it's time, I'll think about changing. Have someone who's there along that journey as a life cycle to think about the different solutions. When you want to move from maybe warmer water or to even warmer water, can you do heat rejection? Do you want to move to liquid cooling, rear door? Those different pieces, that retrofit isn't as simple as it is to say, where you just plunk out a piece of equipment and put the new one in. It takes a lot of planning to do that. So that nature being pulled together, I think that's going to be a big evolution for the data center industry, is now moving beyond that day one thinking of, I'm going to get it built and then I need to get the next one built. But also now, how do I build this one and continually rebuild it, if you will, as time goes on?
Yeah, and having those strong foundations in place. And I suppose that's the beauty of the industry we're in. We don't fully know where we're going, but there's, which makes it a hotbed for innovation, which Trane are certainly at the forefront of. So, thank you very much for your time today, Becky. It's always a pleasure to talk to you. And if anyone watching at home has any questions for myself or the team over at Trane, please do reach out. As like I said, they are really at the forefront of the innovation in this space. But been a pleasure, Becky. Thank you, and hopefully catch up again very soon.